everyone, I have two examples of A1 basic. So first examples given is integral 4y dy, and the second one example is integral 16y plus 4y squared dy. Let's start with the first example. We are solving the integral given. First step, applying the power rule of integration, where n is equal to 1. So applying it the given, we get y squared over 2. Then multiplying by 4. And add the c. Thus the integral evaluate to 2y squared plus c. So let's go to the second example. We need to evaluate integral 16y plus 4y squared dy. Using the integration, we split into separate integrals. For integral 16y dy of using the power rule. Then multiply by 16. This is the answer of integral 16y dy. For integral 4y squared dy, again using the power rule, then multiply by 4. This is the answer of integral 4y squared dy. So, combining both results, the final answer is, this is the final answer, 8y squared plus 4 over 3 y cubed plus c.
Yung given is square root of c plus integral of square root of c raised to 3. Ang ating lang gagawin is, ika-cancel natin si square root dun sa c. Bali, ang magiging given niya is c plus square root of c raised to 3. Ang una natin is solve is c lang. Ang una lang natin nalalagay is i-evaluate lang natin siya. Bali, magiging serpent z to 1 plus 1 over 1 plus 1 dz. So, maging sagot niya lang is z I raised to 2 over 2. Then, yung next naman natin solve is si integral of square root of c raised to 3. I-evaluate lang din natin siya, kaya magiging ano ni z, magiging z raised to 3 over 2 dc. So, ikaw-cancel lang din natin si serpent and si dc. Bali, matitira na lang is si z raised to 3 over 2 over 3 over 2 plus 1. Then, 3 over 2 plus 1 is equal to 5 over 2. Kaya magiging sagot niya is z raised to 5 over 2 over 5 over 2. Yung denominator doon na 5 over 2 is ililipat lang natin si 2 doon sa itaas. Kaya magiging sagot is z2 raised to 5 over 2 over 5. So, i-rewrite lang natin siya. Magiging sagot is c raised to 2 over 2 plus z2 raised to 5 over 2 over 5 plus c. So, ang ating given is integral of square root of c. I-evaluate lang natin siya. Yung square root of c is pwede siyang ma-express bilang square root of c 1 over 2. Yan, i-rewrite lang natin. Then, yan na. c 1 over 2. Yan. Plus 1. Then, ganun lang ulit sa denominator niya. Cancel yung serpent and din yung dc. Bali, ang matitira na lang is cu 1 over 2 plus 1. Then, kaya siya naging 3 over 2 kasi nga, pinag-plus natin yung 1 over 2 plus 1. Then, yung denominator na 2 is, ididikit lang natin siya sa c. Kaya magiging sagot is z 2 raised to 3 over 2 over 3 plus c. Yan yung sagot natin, guys.
Good day everyone. I'm here to explain to you the integral of logarithmic function. The first problem is the integral of 5 over z. The first thing we're gonna do here is express yung function sa way na mas magiging solvable siya. Which is, yung gagawin natin is itaas natin yung z. So magiging integral of 5z raised to negative 1. And next thing na gagawin natin is ilalabas natin yung constant. So, the problem here is, pag in-apply natin yung rule ng integral na to plus 1 ng exponent is magiging undefined yung pinaka-function. So, may special theorems na for this kind of equation, which is pag naka-negative 1 yung exponent is pwede siya i-express as ln absolute of the variable z plus c. So, dito is i-rewrite lang natin sila. So, magiging 5 times integral of z raised to negative 1, which is ln absolute value of z plus c. So, kapag combine na natin sila, magiging 5ln absolute value of z plus c. So that is our answer. So the next problem is integral of 5 raised to z plus 16. So the problem here is yung constant may exponent siya na variable and constant. So gagawin lang natin dito is may integral of 5 raised to z times 5 raised to 16. Pinactor lang natin siya. So ang next is lalabas natin yung constant which is 5 raised to 16. 5 raised to 16. 5 raised to 16. You might think na i-simplify pa natin yung 5 raised to 16 but hindi na. So ang gagawin na lang natin is integrate natin itong 5 raised to z. So, ang gagawin natin dito is may properties for integrating to this kind of problems. Pwede natin siyang i-express as 5 raised to c over ln 5. So, ang ginawa natin is kinapin lang natin yung 5 raised to z over yung ln tapos yung coefficient is just yung 5. So, the integral of 5 raised to z is 5 raised to z over ln 5. Next is, ipapag-combine lang natin sila which is yung 5 raised to 16 times 5 raised to z over ln 5. Magiging 5 raised to z plus 16 over ln 5 plus c. And that is our answer.
Ang gagawin po natin ngayon ay ang trigonometric integral. So, meron po tayong dalawang example. Ang unang natin example ay ang integral quantity of cosecant squared y plus secant squared y quantity dy. Next na example natin is integral of quantity cos y over sin squared y plus y raised to 3 quantity dy. So, ang kailangan natin dito ay ang basic trigonometric corresponding and definite integrals. So, let's start. So, ang first step natin gagawin dito ay hahatiin natin siya para mahanap natin kung ano ang integral ng bawat isa. So, next is hahanapin natin ang integral sa bawat isa. So, meron tayo dito ng indefinite integrals. Dito natin siya titignan kung ano ang kanilang integral pareho. So, ang integral ng cosecant squared y ay negative cot x. So, x ang nandito based to sa nakuhanan ko sa source. At ang ginamit namin sa aming example ay y. So, pwede lang siya magkapalit ng variable pero iisa pa rin naman ang kanyang sagot. So, secant squared y dy ay nakita natin siya dito. Makikita natin siya sa pangatlo. At ang kanyang integral ay ang tan x. So, dahil y ang gamit natin, gagamitin natin ay y. At ito na ang so, ang una natin gagawin ay hatiin rin natin siya dito. So, unahin na natin itong una. Ipafactor lang natin siya. Next, hanapin na natin ang trigonometric identities na ito. So, next, pagsamahin na natin siya para mahanap na natin ang kanyang integral. So, GG. So, next, dahil pwede natin magamit sa kanyang rule. Dahil nandito na rin naman siya sa ating integral. Ang kanyang integral, nakita natin siya dito, ay ito, at pangalawa sa kanila. Ito na kanyang final answer.
Meron tayo dito dalawang givens. So number 1, ang unang step na gagawin natin ay let u is equal to r plus 35 at hanapin natin ang derivatives ng r plus 35. Ang derivatives ng r plus 35 ay du equals dr. Ang 35 is equal to 0 at ang ri equals to 1. At makacancel ang integral at ang du since na-apply na natin ang rule u raised to 6 over 6 plus c. At ang u ay papalitan lang natin ng nasa parenthesis.
So, for the number 2, we have here integral quantity of r raised to 5 plus 18 raised to 4, 5r raised to 4 dr. So, for the first step, let u r raised to 5 plus 18. And we will going to find the derivative of r raised to 5 plus 18. And that is du equals to 5r raised to 4 dr. So, now we can represent the r raised to 5 plus 18 as u raised to 4 du. Integral of u raised to 4 du. U raised to 4 plus 1 over 4 plus 1. And we can cancel the integral and the du. So, we will going back to the inner function. R raised to 5 plus 18 raised to 5 over 5 plus C.
So these are the sum of the example of rational and radical equation. Now for the first example, the given is the integral of z over square root of z squared plus 54. Before we solve the problem, let's rewrite the given the way we understand it. So it will become the integral of z over quantity z raised to 2 plus 54 raised to 1/2. Now the first step is that let u is equal to the inner function, which is the z squared plus 54. Now for the second step is to write the example, but this time we'll write the given, but this time the inner function will become u. Then for the third step, u is equal to the z squared plus 54, which is the inner function. We'll just derivative both. We will just write the u is equal to the inner function, which is the z squared plus 54.
By d over dz. Now, du is equal to z squared is equal to 2z plus 54. Since 54 is constant, we will just write dz over. Then we will divide it both sides by 2. Then cancel, so it become du over 2 is equal to z dz. Now for the last step, which is the step 4, the integral of 1 over u raised to 1/2. We replace the z squared plus 54 with u and z dz with 1/2 du, the original integral. So that's why it becomes the integral of 1 over u raised to 1/2 du over 2. Then the 1/2 is constant, so we can pull it out of the integral. So it becomes 1/2 integral of 1 over u raised to 1/2 of u. Now copy the 1/2 again, and then the integral of u, negative 1/2. The exponent of negative 1/2 will become negative because we reciprocate it. So it's equal to 1/2, then u, then the exponent, which is the negative 1/2 plus 1, will become the denominator. So negative 1/2 plus 1 is equal to 1/2 over 1/2. Now, we will just write the 1/2 and quantity 2u 1/2 c. So it become 2 quantity. The u become, we can substitute it back to its original form, which is the z squared plus 54 raised to 1/2 over 2 plus c. Since they both have 2, we can cancel it. So that's the answer. Now for the second example, which is the integral of z raised to 5 over the square root of z raised to 6 plus 12. Then we're going to write it first and the way we understand the equation. So the quantity will become the square root will become the quantity raised to 1/2. Now for the first step, again let u is equal to the inner function, which is the z raised to 6 plus 12. For the second step is that we write it this way. We will just write the inner function with the letter u, then copy, then for the step 3, u is equal to the inner function, then derivative both sides by d over dx. So z raised to 6, d is equal to z raised to 6 is equal to 6z raised to 5 dz. Now we will divide both sides by 6. So cancel, it will become du over 6 is equal to z raised to 5 dz. Now for the last step, which is the fourth step, we'll just replace the z raised to 6 plus 12 with u and z raised to 5 dz with 1/2 du, the original integral. So that's why it will become the integral of 1 over u raised to 1/2 d over 6 is equal to, since 1 over 6 is a constant, we can just pull it out of the integral. So 1 over 6, the integral of 1 over u raised to 1/2 du. Then we will reciprocate the 1/2, it will become negative. So 1 over 6, the integral of u raised to negative 1/2 du is equal to, just copy the 1 over 6, then u raised to negative 1/2 plus 1. So the exponent of u will become the denominator also.
function, which is the z raised to 6 plus 2 raised to 1 half over 3 plus c.